Today we're going to be working on Leetcode question number 211, design, add and search words data structure. And design a data structure that supports adding new words and finding if a string matches any previously added string. Implement the wordDictionary class. So wordDictionary class initializes the object. Then we have a function called void add word and word. It adds the word to the data structure. It can be mashed later. And bool search word, which is going to return a boolean, returns true if there is any string in the data structure that matches word, or false otherwise. A word may contain dots, where the dots can be matched with any letter. That's another thing. What we're gonna be doing is like using the try structure, the try data structure. So when we have to initialize it, we're just gonna be like setting it all the childrens of the try node. And actually, before even doing that, let's just define the try node. So our try node is going to be equal to, we need to initialize it. Okay, once we initialize it, we're gonna say that it has children, which are basically the dictionaries collections dot default dict. And then we're gonna say it's gonna, all of them are gonna be themselves, they're gonna be try node. Okay, and the other thing is that we're gonna initialize that this is not a word at this point, because we're just initializing it. So is it word or not? That's gonna be a false. So when we are initializing our word dictionary data structure, we're gonna say self root is equal to try node. Okay, so we have the try node. Now we gotta do two functions here. One is the add word. So for the add word, first of all, we're gonna say that we're gonna make a copy of the root, self dot root, which is equal to node. And then for w inside the word, we are going to say node is equal to node dot children and then w. So for the whole word, we're gonna keep saying that the node has a children w, and then that is gonna become equal to a node. So in the end, once we are at the last character, we're gonna say that node is word is gonna be equal to true. Now when the time comes for searching, we're gonna be using the def first search method. So what we gonna do is take a copy of that self dot root. Make sure that we need to set the result equal to false at the beginning before starting recursion. Then we're gonna start the recursion DFS with the node and the root, sorry, word, and then we're gonna be returning the result. Okay, now the last thing we need to do is to define this function the DFS. So our function DFS is gonna take self, it's gonna take node, and it's gonna take the word. There are a couple of base cases here. What if there is no word? That means we just need to check that whether or not, because we're gonna be every single time during the recursion, we're gonna be removing the first character and sending the rest of the substring into this DFS function. So that means if we are left with nothing in the word, we're gonna check that if the node dot is word, basically if it is a word, we're gonna just return the true self. First of all, we're gonna set the result equal to true, and then we're gonna be returning. Okay, and other base case is gonna be, what if it is a dot? If the word, and basically every single time in the DFS function we are processing the first character only. So what we're gonna do is word 0, the first character, if that is equal to a dot, that means that we definitely need to progress and call the DFS. So for n in node dot children dot values, so we have to make sure that we go through all the children of the node, because it can be anything, right? And then self dot dfs of again that node, sorry, that n, because uh, this one we're gonna go through all the values of the children, and the word colon 1, so we are just truncating the, sorry, 1, and then everything after 1. So basically we are truncating the first character, and then we are calling the DFS function. Basically means that if the first character is a dot, just go through all the values of the children, and then try to like use the DFS on all of them. Lastly, we're gonna say that now we know that the node is gonna be equal to node dot children dot get word of 0, if not node return, right? And then we're gonna keep using the DFS of that node and the word 1, just like we did over here. Okay, if not node, we're just gonna return it, because basically this is the decision point here where the word is not there anymore, uh, and we're gonna check if it is a word or not. And but in case if it is not a node, that means we just return it whatever the value was before that. That's gonna be it, because we don't even need to set it, because we initializes the uh, initializes when we are in the searching, when we are searching, starting the search, we are setting it to false, and then we just keep recursing for the next node. Looking good. Time limit is exceeded. So we have initialized it, checking the word, the add word here, that we are setting the, we are making a copy of that, and for w in the word, we are progressing, and then getting the true, and then in the search we just do node, basically we do is checking the root, setting it to false, calling the DFS function, and then we check the result. Now let's look at the DFS. So the first thing is that if it is not a word, if the word is like is null or completely an empty string, I check that if the node is a word or not. Right? If the node is word, we return. Are we returning after that? We are returning. Yes. If it is true, we just return. Yes. Then in this case where word is done, for n inside the node dot children dot values, we are saying that self dot dfs n and then word of that, looking good. And then we do else node is equal to children dot get word. So everything looks good. Let's try one more time. And it works. So it is slow, but it does work.